Hello guys, this is Riyad and I'm gonna talk today about the Thèvenin equivalent circuit and the Norton equivalent circuit, and after that the principle of superposition. Now to start off, I'm gonna just define the Thèvenin equivalent circuit. So let's suppose you're studying a resistor, a capacitor, or an inductor, any load particularly, and it's the circuit around it is fairly complicated and not easily understood, so or not easily studied. So what we tend to do is that we simplify the circuit. We find the circuits that equivalent to that one, and it's very simple. It consists only of a voltage source in series with a resistor in series with our load, or a current source in parallel with the resistor in parallel with our load. That way it's going to be much easier studying that circuit. So to start off, uh, I'm gonna solve this equation, this circuit here. I'm gonna simplify it between the terminals A and B. I'm gonna find both the Thèvenin equivalent circuit and the Norton equivalent circuit. So to start off, I want to find V Thèvenin. V Thèvenin here, I'm gonna find it using the mesh current method. I think that's the most convenient way to find it here. So let's start assigning the mesh currents. In the first mesh, it's just 12 amps, so I'm not gonna assign any mesh there. In the second one, I'm gonna call it I1 and it's clockwise. And in this third one, I'm gonna call it I2 and it's also clockwise. Now let's start writing the mesh current equations. So let's start off with 30 into I1 minus 10. I'm sorry, this is a 10 here, not a 12. Mistake. Okay. Plus, that's just 13. The two resistors there are just gonna add up to 13 into I1 minus I2 is equal to 0. And the second mesh current equation is minus 500 plus 13 into I2 minus I1 plus 12 I2 is equal to 0. If we are to solve this mesh current equation, we're gonna get, I'm gonna take out my calculator and start solving this these equations. So we have here is, I'm sorry, give me a minute. So it's gonna be the first one is I'm solving it, bear with me, I'm sorry. So that gives me a value of I1, that's 8.002. I'm just gonna write 8 is 8 amps, and I2 is 24.16 amps. Okay, so now to find the Thèvenin, it's particularly easy to just apply Ohm's law over this resistor here. So V is equal to RI, and I is 24.16, and R is 12. So we get V Thèvenin is equal to 24.16 times 12. That's equal to 290 volts. Now that's V Thèvenin. Now to find R Thèvenin is much easier. We just set all the independent sources to 0. That is a current source, take it as a rule. A current source is an open circuit. And a voltage source is a short circuit. So applying what we know to the above circuit, we get I'm just gonna erase these. This is a short circuit, so it's gonna be like this, and this is an open circuit, so I'm just gonna delete it. It's not there. Let's get rid of these two. Now this is my circuit. Using simple, straightforward simplification methods of resistors, we see that 30 is in parallel with the sum of 8 plus 5. That's 30 in parallel. That's, I'm sorry, 30 in parallel with 13, which is equal to 9.06. And now we have this 9.06 is parallel also with the 12. So we have again 9.06 in parallel with the 12, which gives me 5.16 ohms. So we got R Thèvenin and V Thèvenin. Now all what we have to do is construct the circuit. So V Thèvenin is 290 volts. That's this. Plus minus 290 volts. And the R Thèvenin is 5.16. This is terminal A, this is terminal B, whatever is in between them anyway. Now finding I Norton, we could find the short circuit current here. I'm sorry. Here when the voltage source and the current source are there. So we have here 500 volts and here 10 amps. We can find the short circuit current here. That would be I Norton. But since we found the Thèvenin equivalent circuit, I Norton actually is simple, straightforward. Using source transformation, we can know that the current source will have a value of 290 divided by 5.16, and that is 56.2 amperes. So the Norton equivalent circuit is just 56.2 in parallel with the same resistor. So 5.16 in parallel with our load. Wonderful. We just simplified the fairly complicated circuits into this cute thing. Now I'm gonna solve more complicated examples, hopefully, about the Thèvenin and Norton equivalent circuits in the upcoming videos. But now I'm gonna talk about the principle of superposition. Feel free to ask me any question in the comments below. I'm gonna try my best to answer all the comments as possible, of course, and send me emails. I'm I'm gonna try also to reply all my emails. Now, I'm gonna give you a circuit, something like, um, let's say, oh, let's use the same circuit of above. Let's say this is 10 amps. This is a resistor, let's say 50 ohms. I'm gonna use the same one, I'm sorry. Let's say I have here a voltage source that's 50 volts and the resistor here of 10 ohms, and I have a resistor here of 20 ohms. And let's say I tell you I want to know the current through the 20 ohm resistor. Now, well, you can use mesh current method, that's straightforward, but if you were to use the superposition method, the method simply says that the current flowing through this 20 ohm resistor, let's call it I1, is the sum of the current caused by this guy here and the current caused by this guy here. Let's use colors, that's not distinguishable. So by this guy right here. So I1 is equal to I1 prime plus I1 double prime. This originates here from the voltage source, and this one originates from the current source. So we just set when we find the one I1 prime, the one originating from the current source, we set all the other sources to 0. So this guy right here, the voltage source, is just going to be a short circuit for now. So bye bye. And it's simple, straightforward. We just use a simple current divider rule, and we get that first let's find the equivalent of the 50 and the 10. And that's gonna be 8.3333. So the current divider rules tells us that I1 prime is equal to 10 or minus 10, because it's in the opposite direction, times 8.333 over 28.333. And that is minus 2.9 amps. And now, after finding the current caused by the voltage source, it's gonna be, let's set this one to 0, it's gonna be an open circuit. That's why we're gonna erase it all over. Now, the voltage source here is 50 volts. Now the current caused by this guy is gonna be equal, well, a current divider rule once again, but we need to find the equivalent resistance of all of them, and then use the current divider rule or use mesh equations. I'm gonna go with the divider rule. You know how to use the other ones. I'm just gonna find that fast. And the equivalent is 56 ohms. So our equivalent is equal to 56.6 ohms, and and the current, the total current here, let's use a different color, no, not this one. The total current here is equal to 0.88. Now using current divider rule once again, we have 0.88 0.88 times 10 over 30. Now it's again minus 0.88. So it's gonna be equal to 0.29 amps, minus 0.29 amps. So the algebraic sum is gonna be equal minus 2.9 minus 0.29, that's gonna be minus 3.19. So I, which is equal to, I, which is equal to I1 prime, which is equal to I1 prime, which is 2.9, minus 2.9, minus I1 double prime, which is minus 0.29, as a plus, is gonna be equal to minus 3.19. You see, this method is particularly useful when the circuit's more complicated than this, but I'm just want to give simple, straightforward examples so you can understand it. I'm gonna give much more complicated examples in the next videos, hopefully. Now, I really hope that you liked this video. I really would appreciate it if you give me a thumbs up and subscribe for more videos. And until the next time I see you, bye.